When will we be able to see free energy devices powering consumer products like this electric car? Well, they're already here, and you may be able to purchase one by the time you see this program.
In Oklahoma, where oil has been king for over a century, inventor Troy Reed has been busy in his shop constructing rotating magnetic motors that he believes will soon revolutionize how we get around.
And it does work. This is a new prototype of the magnetic motor, and if I can explain a little bit about what you call a magnetic field. All magnets, the big old wooden prototype, has a system. As the motor went over, it had a tension to jerk over like that. If you take this motor here and you take your finger and rotate it, it doesn't have that jerking in it. So what I've done, I got rid of the crankshaft. I've got rid of the injectors, and the system in this motor here, as you crank this motor up, and like you do the other one, the motor will start running, and what I'll do, I'll energize it on this motor here. If you can see these amp gauges over here, this will come, when we get it up to about 150 volts, we'll unplug it and we'll turn the light on. If you turn this around where you can see this side here, all the working parts is behind this system here, operates from a little computer. Takes just 5 volts. It's 150 volts. What we're going to do, turn off all the switches, make sure there ain't nothing plugged into it. There's the plug. There's your 110 volts. Motor still running. You can operate this table plumb around. Still got energy running. Nothing tied up in the back of it. Nothing on the floor. Rotate around, still running electricity. So we're looking, hoping this time next year that you'll be able to use it in your home. So that's another. And what's good about this, you're talking about electric automobiles, this right here can set it in the back of an electric automobile and generate electricity and charge batteries up in a car. Beautiful automobile. You can drive it anywhere you want to. You don't pollute the air. All the other electric automobiles that I've actually seen has been nothing but this standard transmission. This is an automatic transmission car. There's not a whole lot of what you call junk, I would call, under cars. I've seen a lot of electric cars that had a lot of stuff in it. The only thing that this has a battery to run the radio, the blower. We've got 2 safety switches over here that can be mounted into an enclosed system, but we did this where you could see, where people can see this car with the technology. It's a safety switch system. This is a controller box, a Curtis control box. It cuts the amperage down. So with the amperage, here's what's real good about electric automobiles. All electric automobiles that has surge technology with this in it, they create heat. They've got to have a fan to blow this this Curtis controller off because it gets hot. We don't want that to get hot. We want to stay that cold, because once it stays cold, you save on all the computer chips that's in this controller. So that means you can go farther, longer, and you won't have no problems. This Electro automobile has got two gauges in front of the shifter on the automatic transmission. It's called the voltage and the amperage. That's what I was talking about earlier about amperage on automobiles. Let's see if we can't get the amperage to go down instead of going up. The voltage on this here should say somewhere around 120 volts. When we start out, there's no amperage at all. So the gauges is down below here, and we're getting ready to take and go drive the car, and you can see for yourself what it does. All you do is to take and put it in gear, and the motor sounds like a little sports car. Shifts, runs good, fantastic automobile, drives. If you'll see the amperage on the gauge, see it going down? Amperage goes way down. That's what I like about electric cars. If you floorboard the car, the most it will do would just be about maybe 100 amps. And that's what we want to do, is to keep the amperage down on an electric car. So it'll go anywhere really anybody wants to go. If you want to take a trip, you don't have to worry about it going to go plug in the house, because it's called the surge technology. It's a beautiful automobile, and I love it, and I've put a lot of hard work in this car, and we're going to make it. No oil, no gas to fool with. And the technology is here. It's going to be here. It's going to go. It's going to work beautiful for the whole world, for mankind. See you around. This is your future, people.
As we have seen so far, electromagnetism seems to be offering the most viable path for many contemporary inventors. The magnetic motor continues to challenge the over-unity barrier, but even simpler methods are being demonstrated through common ingenuity. Dennis Lee of Better World Technology has been struggling to pursue his dream of achieving energy independence for everyone on the planet. Held in prison for 2 years without ever being convicted of a crime, Lee mounts public demonstrations in major U.S. cities, lining up individual dealerships to market his devices. A controversial figure, who some dismiss as a fraud, and others see as legitimate if outspoken P.T. Barnum of free power to the people, Lee has assembled an impressive line of prototypes and processes, including those by other inventors like Yul Brown. Although he claims his machines are not utilizing zero-point energy because they draw heat from the surrounding air, his numerous devices supposedly achieve super efficiency rates by recycling excess energy through closed-loop systems.
I built the world's most efficient heat pump and developed it, and these are the evaporators for that heat pump right here. They're 8 feet high, 3 feet wide. Now, the refrigerant we put in here boils at 40 degrees below zero. Therefore, anytime, day or night, outside in a rainstorm or in a windstorm or hailstorm or a snowstorm, or just out on a nice hot sunny day or in the middle of a cold night, as long as the refrigerant that's inside this panel is colder than whatever the air is out here or the phenomenon that's hitting this panel, then the heat from the air or the sun or the wind or the rain or the sleet or the snow will be transferred into the refrigerant on the other side, because it's the second law of thermodynamics. Hot goes to cold. So if this is the coldest thing outside, anything out there that touches it is going to give its heat to it. A little bit of heat goes a long way. That gas starts expanding like crazy, and as it expands, it then is drawn into the compressor, not through suction. I've got engineers and inventors that don't like to use the term suction, but through negative pressure. So as the compressor is creating this negative pressure, the gas is migrating to it. And so a compressor is a gas pump. It'll pump gas. And so the gas is being pumped by the compressor into the compressor, elevated in temperature. And even though if you touch this panel, it's ice cold to your hand, and if you touch the line going out of the panel, it's still ice cold to your hand. When it hits that compressor takes all the gas in this space, puts it in that space, elevates the pressure and the temperature. Going out of the compressor, do not touch that line whenever that thing is on, because it's 200 to 250 degrees hot. And so that's where we get the heat. All of the heat is transferred in here. We then use a compressor to take the relatively useless energy that we've got and elevate the temperature and pressure and make it very useful energy. Then that heat would be transferred later. This is a direct drive compressor. This direct drive compressor takes Freon from the panels, and it runs that because this direct drive is causing the pistons to go up and down. That gives us heat into the boiler. The boiler expands the other Freon back through that into a double-acting piston that's going back and forth. We're converting with mechanical apparatuses. We're converting that into shaft rotation. That shaft rotation turns this wheel. As this wheel turns, it causes the compressor to turn. As the compressor supplies the heat, it causes this wheel to turn. You might say these two wheels are powering each other. And by the way, once the Freon has taken the heat, it then made the power, it then goes up here. This is a condenser. We're sucking water out of the bottom of the tank, could be the well, and we're running the water through this pump right here that's also driven by the same drive mechanism, running the water into this condenser. It's the world's most efficient condenser at 100 degree delta T, 6 million BTUs. And as we're then running the water through, we're making the water hotter, but the water will also be being pumped. And as I do this, I'll show you the water being pumped. And then also, we're cooling down the Freon, which is going into this canister and is being pumped right back into the boiler by a little trombone pump that's running on the same cylinder. You ready to try it? Let's go ahead and try it. Let's turn it on, guys. Okay, if you're ready, Maestro, anytime you're ready. Okay. So it is pumping water from energy taken out of the air, and we'll light the lights too from excess energy. So the lights are being lit from excess energy from the air. They're pulsing. It wasn't set up to do that, so we don't have it stable, but we thought we'd just demonstrate the excess power that we have. Main thing is it's pumping water. It's supposed to be pumping water. That's a closed loop because it's continuing to go through the boiler and then back. I had a heat pump in a walk-in freezer. We cranked the temperature down to 20 degrees below zero in dead airspace. Now imagine this, if you got any background in refrigeration, we're in dead airspace, the temperature's 20 below zero. We did it every single Saturday for an entire year. People from all over the world came to see it. We said, bring your own test equipment, take the thing apart if you want to. We had a $10,000 challenge to find any gimmick or anything in it. And every single weekend, we cranked the temperature down to 20 below in dead airspace, and we made water hot enough to burn your hand from energy we took out of that box at 20 below at a 2-to-1 COP. Same average performance of the GE heat pump in America. Only it's 20 below in dead airspace. And we challenged all the heat pump manufacturers to come anytime you want to, either find a hoax with us or bring your unit down and see if you can do that. Nobody ever came. A lot of customers came, lots of people from all over the world came, Pakistan, everywhere. So anyway, we're in here testing this every year, every weekend for a year. And a man came to the show one day, and what a guy this was. Now we're trying to build this thing. It's going to take 2 years and $2 million, and I'm raising capital selling heat pump things to get the money. And a guy walks in and he comes up to me at the end of the show and he says, Mr. Lee, I am absolutely astonished. I want to shake your hand and I want to tell you, I have no doubt you have got the best heating system in the world. Yours tops everything out there from solar all the way down the line. You did it. But you need to know me. You know why you need to know me? Because I have built the world's most efficient heat engine, and you have got the world's most efficient heat source. He says, if we got together with our two technologies, we could become the most dangerous men in the world. I thought, wow, I've never been the most dangerous man in the world. I've kind of wanted to be. And so, you see, this man's name was Dr. Fisher. Now, this guy proved that they built the steam engine wrong. I had the pleasure of building his unit in my research lab, and we took his great big unit, because why wouldn't I want a great big one? I don't want to put everybody on the grid system with a new system that can exploit them some more with all the arrogance that comes with it. I wanted to give people the opportunity to be totally independent of the grid system. Remember, that was my goal. So we took the big one we had and we scaled it down into a model not much, a little bit smaller than this one. It was a little smaller than this. It was about that long. It's about 13 inches long, 6 inches in diameter. And that one was going to be big enough to be able to power all the energy you needed for your house, and so I didn't want one bigger than that. And by the way, that little unit could fit in the glove compartment of any American-made car. I went across the United States of America telling my story. I told it in every state of the United States, and I got 1,000 people to join me telling my story. We put a media ad campaign together because the media wouldn't cover it, so we ran commercials. And we did a 60-second commercial cutting a power line and saying you can power your house with no electricity, external electricity, run your car with a new engine that runs with no gasoline. We did a 60-second commercial nationwide. As far as we can tell, about 10 million people saw it. And after that happened, that was too much. That couldn't be tolerated. And so I got a letter from the state of California inviting me to come back to California to go to court. So I flew back from New Jersey to California to go to court, and when I walked into the court, the judge said, "You're probably wondering why you're here," and I said, "Yes, I am." And he said, "Well, because I've been ordered by the state of California to put you in prison." And I said, "Well, that's really interesting. You're putting me in prison, but I've never been convicted of the crime. How do I go to prison without a trial and without being convicted?" And I said, "You can't do that, can you?" And he said, "Well," he says, "I've been ordered by the state of California to put you in prison, so that's where you're going, but sounds like you got a hell of a case for appeal." That, by the way, is a quote, and I do have the transcript. I walked out of prison 2 years ago, and now we have rebuilt our whole national network of distribution of distributors. We're in every state of the United States. We're in every major county of the United States. We have people now who understand exactly how the government works, exactly how the big boys work, exactly how the energy companies work, and we've got it all figured out. And we've got far, far, far more technology than we ever had in 1987. We got a lot more money than we ever had in 1987, and we're about to rock your world.